I wanted to talk about Angular, but I think it's much better to talk about nature. Please raise your hands, guys, who like nature. I was right. Just imagine you are in a forest. You are walking and there are beautiful trees around you. There are squirrels and other animals and you want to make a picture of every animal you see. There are many landscapes and you probably enjoy this travel and trip you have. There is a shining river on the left-hand side. It's shining in sunlight and there are mountains behind it. You know that there is going to be a long way, long journey. But you are happy because you know that there is some cool, really nice house you booked in those mountains. You spend half of the day hiking, and it might be an easy task if you wouldn't a software engineer and you're not doing sport that much, so you're kind of tired. You can see this village. You remember that there is some house, but you don't remember where exactly. You remember also that you have a mobile phone with minimized browser and your reservation confirmation in your pocket. You pull your hand into your pockets and you take your mobile phone, you open the browser and you see this. Unfortunately, it's quite a usual experience you can have using your mobile phone outside the city center. And unfortunately, I've seen the screen quite a lot. And you may have seen it either. Also may see this, and in more scenario with this. And when we work on websites, it definitely makes sense to consider that our users can be in such situation. So my talk is about mobile-friendly websites. I will do it in context of Angular. However, many advices I could give you, you may use in other technology and they might be applied. A little bit about myself. I'm working full-stack JavaScript engineer. Also, I do several own projects. They are really weird. One about analyzing of DNA sequences and providing the list of your health problems. And another one about automating the meals in mines and processing plants with machine learning. So, I think we can start. First of all, I want to start from the most painful topic for JavaScript developers nowadays. Like, some things are really ridiculous and some things are really big, but nothing could be bigger than contemporary JavaScript bundle, of course. And I need to go a little bit deep into the history just to explain how it was years ago and what we achieved as a community during the last several years. So, initially the idea was that we'll have some HTML, we'll have some JavaScript file, probably some configuration in JSON, picture, some styles, and it was quite okay until our web became a little bit more complicated and it started looking like this. It's also okay if you're using HTTP2, but, well, who is using HTTP2 here now in production? That's the problem. That's why some solutions vary, because when you open this HTML in a browser, it starts pulling pages and it looks like this. You put this batch of files, you pull next batch of files, and afterwards you wait. Like, it takes some time because it's just protocol expenses you need to pay. There was another try, like what could happen afterwards? Well, we can unite our JavaScript file into one file. We'll have the same file size, I mean common file size, but we'll save some time on these protocol expenses we pay. Okay, it worked out and it already solves part of the problem. Also, you can unite pictures, you can use some kind of sprites, you can unite those JSONs, you can unite styles altogether, but conceptual idea is the same. And in the era of those grand and gullible bundles, there are projects which had weight like 20 or 30 megabytes even. I've seen the production one clients like this. So afterwards, community realized that something needs to be changed, and we decided to, okay, we can pack everything in one JavaScript file. We can also minify JavaScript just because why do we need not minified files? So it became a little bit smaller. And okay, it still has some junk in there, some garbage. For example, you're using Wodash and you're using just the bounds function of the Wodash. Why do you need whole Wodash? So you can get rid of it. And this process is called Tryshchenko, like elimination of dead code. And it's quite a good conception, which gives us good results, but not always. That's why there was another try, that if you still have some big bundle, you can split it into several parts. Like you have application with several pages, and you can just split these pages into chunks, like code which is responsible for some particular page. And for example, user opens dashboard, you want the framework and code which is responsible just for this dashboard. Afterwards, user is going to say profile page. He clicks profile page, and with the requests for data we need for this profile page, we just wrote JavaScript which is responsible for rendering of this page. Here is a problem that all these techniques are more or less implemented in Angular, but some of them are not supported. The problem that Tryshchenko isn't properly working yet, and it becomes better because the original compiler was even worse. There is a new compiler which community is working on. It's called Ivy, but it's still not yet released. And lazy loading isn't working out of the box. You need to put efforts to make it work. And I want to show you something. I just created a simple Angular application, just hello world application. And I just added two modules. First one, Angular Material, and the second one, I added progressive web app support. That's it. There is no any codes and any third-party libraries. So first of all, I need to do something like this. Okay, just a second. It's a little bit more than I expected. Okay, so I think we can go. I created a preset which is called forest, where I set approximate speed which you can have outside the city center with some really weak 3G or even 2G internet, and I'll just hit it. And currently this page is loaded from cache because I use this web worker stuff, but let's get rid of it. Sorry, let's do something like this. Yes, it's offline, and you can see that it is loading now. Oh no, it's not. Sorry, it needs to be removed. Sorry, I confused you because I haven't run the server itself, but it was opening from offline. So, okay. Okay, let's go. It started loading. I'll make it a little bit bigger. It is minified bundle with out compiler, which makes it as small as possible, and it simulates some 2G connection. Okay, so we have 25 seconds just to get our application up and running in the first place. Of course, if I'll use service workers, it will refresh faster afterwards, but it's really a problem. And if I'll go out of here and I'll do something like this, you can see that bundle, minified bundle with 2 libraries added is almost 700 kilobytes, and it is just Hello World application written in Angular. So you may ask me what to do, and I may ask you, you need to wait, because it's the only thing you can do currently, or avoid using some libraries for Angular and trying to reduce it as hard as possible, or just live with such bundle size, or wait till Ivy gonna be released, because with Ivy you get possibility to do this dead code elimination, and you can get possibility to have like 300, 400 kilobyte bundles. Also, just small advices that it makes sense to use different image sizes for different resolutions. There are some libraries independent from Angular which can prepare assets for you. You can use lazy loading to load some heavy content, like you can just render initial screen and load some additional stuff afterwards. And adding libraries which react to with Angular CLI, it can save you and prevent from writing useless code which is going to be compiled and take space. About CLI with new Angular, which was released like 2 weeks ago, they added a possibility to pre-configure some libraries you install, and like here is process of installation of Angular material libraries, so you can just choose configuration. It asks you several questions like, do you want to recognize gesture, do you want to have animations, and afterwards it will configure everything for you, so you don't need to write some boilerplate code, which I think is pretty amazing. Next one is offline use. I think many of you have been to presentation about PVAs already. It was so amazing, and I won't focus on it that much. I'll just highlight conception for guys who haven't been there. Like, process is quite simple. User hits a website, browser checks do you have this stuff in cache or not. If not, browser fetch results and saves them to cache. And afterwards, if user opens the stuff offline, he can get results out of the cache. How to update this stuff? There is a nice thing which is called HTML5 push API, which allows you to get updates in background, like for example you have changed something, and service worker is going to be notified that something has changed and it will receive data. Unfortunately, this technology isn't perfect, but it works somehow, and not everywhere. Like Safari is still not supported. And so, when you got this push notification from the browser, you just fetch resources and save them to cache back. And when the user will open the website the next time, he will get actual results. And he haven't had just to not open, but form his cache manually. So it works something like this, and it just updates your code, not code, but cache on demand when something has happened. Written solutions, I would say yes, and all modern frameworks have more or less support of it. In the first place, because you can start with some basic stuff like manifest.json. Also, there are packages for React and Angular. For Angular, there is official package you can add with Angular CLI, which supports all the stuff. And demonstration, I demonstrated you when I opened website offline. It was just added with a command to empty project like ng add Angular PVA. I haven't configured any line, I haven't even opened my code editor to do so. And it works, which is amazing. Unfortunately, market of mobile browser looks like this. There is a huge amount of coverage of US browser. Luckily, it is just Chinese guys who exploit all statistics. Also, there is this browser. Luckily, it is written on top of WebKit, and it's not that bad as I thought in the first place. And generally, you can run progressive web apps on 93% of browsers, which is quite good. However, you couldn't receive those HTML5 push notifications on mobiles. And of course, UC browser doesn't work, but I don't think you really care about it. What's new? Chrome announced that you can currently install progressive web applications as applications on Windows and Linux. There is nothing known about support of macOS, but it also could be pretty good, so you can do the same as you do on mobile on your desktop. There are also concerns. I had experience writing service workers, and there is a question of data integrity if you're trying to fetch some stuff which is more complicated than just pictures or some assets. Like you're trying to make some requests in the background, and you need to track what happens. And if you support some offline actions, for example, it's some application which allows you to create nodes, user add nodes, and you know about it locally, but how to update the server that user has done something locally afterwards when user will be online. So it caused some inconveniences. Also, post requests couldn't be sent. There are some security reasons behind it, but it's still under discussion. There is a big topic on GitHub. You can follow if you want. And by the way, all links will be available in the presentation. I will share it afterwards. And yes, Push API doesn't work on every browser, which is said. And so far there are no declared commitments from Apple that it's going to be supported. So, okay, what's about data? So I mentioned how you can manage assets. I also mentioned that there is some data and you can manipulate with this data. So what could you do? In Stone Age we had cookies only, and it's a bad idea to store anything in cookies if you're talking about data because they are small, and API is pretty old, and well, there is no reason to do so. There is local storage, which also was used for a long time, but it is smaller. There is IndexedDB, which I suggest to focus on. There is WebSQL, which is outdated, and there is file system, which was a good idea of Google. It allows you to store some files inside the browser cache, like you can have virtual file system, and if user uploads some file, you can store it there. But it's not supported outside WebKit, and it hasn't become a part of specification, so it's not going to be supported in other browsers anymore. And you may ask me what you can do. First of all, I recommend you using a library which is called local forage. It's a wrapper which allows you to eliminate the difference between four platforms and use local storage on platforms which do not support IndexedDB, and use IndexedDB on platforms which support it. But it's quite basic. If you want to make some queries to data, some complicated get stuff, it isn't gonna be a good choice. And what else? Like, well, probably you don't even need a wrapper because all modern browsers, as you can see, already support IndexedDB in one or another way, and there are many common specifications you can use. I want to talk about performance also because it's very important stuff, and I've seen several applications which are like have markup for mobile devices, but they couldn't be properly run on mobile devices because I click button, it started lagging, my phone becomes hotter, it started throttling, and it becomes even more laggier, and I just get afraid that it will explode in my head. So I couldn't go deep into this topic because it deserves a separate presentation about it, but Angular change detection, it was designed in the way to prevent you from making mistakes. If you're not afraid of making mistakes, you can play with change detection strategies. There is just wonderful article how it works, and it was the first stuff to read, after which I understand how does change detection finally work. Also, there is stuff which is called virtualization. I have a separate slide about it. GPU's animation are much faster than CPU animations. I will show it also. And well, yes, it's all about data. If you have many repeating components, probably it makes sense to split them in separate pages. It may differ from design you expect to have, but you can poorly benefit of such decision. And caching and memoization, like, it became quite popular to use Redux for Angular, and Redux is good technology, but it brings their own minuses. And if you're using Redux, probably you're familiar with stuff like selectors, like all this memoization around it, just to prevent stuff refreshing so often. So it looks something like this, and yes, DOM operations are expensive. Everything what we have about performance in DOM, it's about in JavaScript, it's about DOM operations. So like all those technologies, virtual DOM, shadow DOM, or Angular's abstract syntax tree, they are redesigned and created in the way to check data before actually rendering it in the page, because rendering is the most expensive operation you can do in your browser. So yes, solution is obvious. Unfortunately, we couldn't always afford it to have less elements on the page. But in the last Angular, they added like built-in virtualization, and you can see that it's kind of virtual scroll. And during the scrolling process, they change pictures which are in container, just adding one picture before and one picture afterwards. And it is something what I personally waited a lot because we had to implement it several times on our own. Especially it is noticeable if you have some big data grids, and in those data grids you have some cells which are smart cells, for example buttons, or you need to change some stuff, and you have those horizontal and vertical scrolls, and it goes too deep, and you it's painful. And this stuff really makes life easier because it's something what really makes sense to implement. And don't update elements without reason. Also, I want to show you an example that's basically GPU animations aren't slow. It might be a little bit laggy because I'm recording my screen now, but I think I need to make it a little bit smaller to fit it onto the screen. Oh, okay, it's hard. I can pick smaller screen, I think. Is there a iPhone SE? Yeah. So you can see that if I click submit button, or just I need to update it. Yes, so submit button, some options, all this stuff is quite smooth, and it is just some CSS transitions on top of changing elements. And all those models can be implemented this way, and those operations are quite fast. So you can really achieve these 60 frames per second easily on your device, and it's not a big problem anymore. The problem is how we manage the data and how often we trigger DOM updates. Also, I want to talk about design for mobile devices, because it's easy to make application not usable like this one, and also some topic which are related to it, like accessibility, native feel and look, animations. First of all, when we make applications, not applications but websites for mobiles, we shouldn't forget that people used to use their mobile phones with one hand, and moreover, like people use mobile phones with different hands. Like there are people who use it with left hand and people who use it with right hand. And like you can see the zones. Green zone is a place where it can be through like surface which can be easily accessed by finger. Yellow can be accessed harder, and red is hardly accessible without doing something like this. And it makes sense to just unite the zones and put something like in this grid zone. It's very, very subjective and just illustrated because people have different hands. They would take mobile phones differently, but the idea behind it, that stretching fingers to the left top corner of your mobile phone, which is, I think, how now, 6.5 inches screen, it's kind of hard. We need to take care of accessibility. I won't focus on it also because it's quite wide topic, but when we develop websites, think that people on mobile phones as well as desktop users can use some accessibility tools. And on mobile device they have some special toolkit which allows them to navigate through the screen with their fingers, and it will read them aloud what is happening on the screen. There are some special tools you can use, and there are some standards like AA and AAA. I've given a separate presentation about these standards on Grid.js, and I hope there is going to be video available soon from it, so I think I'll also share it. But usually this standard is going to be implemented. Many institutions in Europe are enforced to implement the standards by laws. And those laws are already present in UK, in Germany. There are some such laws in Australia and Canada. And I think they will gonna expand. And also there are like some sub-part of specification, like this way area. Probably you've seen this area text. They're really not hard. About UI, there are many libraries which can save you some time, because when you develop mobile application, most likely you expect user to have some native experience, something what won't frustrate him and will help to use this your website as a part of their infrastructure. Especially it is useful if you're developing a website which is going to be used once. For example, I had an incident in Belgium when I wasn't a resident of European Union. I had a very expensive roaming in Europe, and I traveled to Belgium and I had to purchase a ticket. I was in a bus station, and there were two options. First option to go like 2 bus stations to the ticket machine and purchase it for cash, or purchase it through the mobile application. And the size of this mobile application was 260 megabytes. And I had to decide, okay, either I pay like 20 euros to download this application and purchase ticket which I would purchase only once, or just go there, buy food and purchase it physically. And the problem that we create applications for stuff which doesn't really require application, for operations which people will do only once. And if you do something like this, it makes sense to use some web application instead. And for mobile web applications, there are many libraries. Like Ionic framework, it's also known in Cordova community because you can build some hybrid application with it. But you can either build a progressive web app with it, with interface which will be similar to mobile devices, like all those buttons, scroll views, all those forms, they will look native for user who is using it. And also, depending on the platform user opened your website in, it will display a little bit different UI depending on the platform. Like if it was iOS, it will use iOS elements. Otherwise, it's going to use this material stuff. There are separate libraries like Angular Material, which allows you to save time working with animations, with design of those buttons and elements itself, and other stuff. I wouldn't highlight all those. But another point, it is like undesigned mobile. It's not for Angular, but if you're working with React, it's just golden. It's probably one of the best solutions for mobile UI I found in the market. When you're working for creating a website for mobile, there is just a simple checklist how you can verify yourself. Like just make sure that it works fine on small devices, because well, on small iPhones sometimes things are really spoiled. Make sure that it works on big devices. It works in horizontal orientation, because many sites don't. Safari and Chrome are supported, like screen readers can read through the stuff on your screen, and website is zoomable. By the way, zoomable website is very important stuff. Like many of us used to put this meta tag which prevents site from being zoomed on mobile devices. It's a direct violation of accessibility standards, so we couldn't use it. And yes, you use different images for different resolutions. Like there is some really small screen on small iPhones or Sonys, and really big screen on Samsung Galaxy S9, for example. Also, when we are creating websites for mobile devices, we could remember that using some native APIs isn't something what good mobile applications do anymore. Like you can access big variety of APIs from web applications. The most obvious, you can define which keyboard type is going to be used depending on type of contact you expect to get. Like if you're asking people for a password, you can display one type of keyboard. Then you're asking for emails like this. You can display this type of keyboard with useful symbols, either to prevent user from clicking this button and choosing symbol. Or for example, if you're asking just for a number, you can use number keyboards. And currently it is easy as just using some HTML text. You can easily request location of the user just from your web application. There is no any rocket science behind it anymore. And you can easily access camera, you can easily access sound from the mobile device. And again, it is the stuff which works in all modern browsers. And you don't need to put any additional layers or plugins or applications to use it. So, what is it all about? The thing I wanted to highlight is that we have all tools which can help us to create a good mobile web application. We can learn how to create web applications which are usable offline, which are usable with weak connection, and web applications which work properly and load fast on mobile devices. We have all tools which allow us to use good UIs for web apps, but for some reason we still have plenty of websites on the market which are totally not usable on mobile devices, which you need to wait and you need to zoom and some UI is overlapping other UI and stuff like this. So I guess that's it. Thank you, and I'd like to ask you answer any questions if you have some.
Is there any?
That's it, please.